Okay, welcome to this video where we're going to talk about the introduction to functions. So specifically, for you to understand fully what functions is all about, you have to understand some of the keywords that we're going to make mention before we even go into the details of the so-called functions. Okay, so remember, like I said earlier, we're talking about functions today. This is just introduction to functions. Alright, what are the things that you have to take into consideration for you to know if a given expression is a function or not? Suppose we have two different sets. That's why I even told you, I even encouraged you to say go first into the document that we made for sets theory. So what does it take for you to understand fully to say this is a set, this is a function and the like? Suppose we have two different sets. We can have a set of the first part and then the second set in the second part. So specifically, these you have to label them as letter with letter X. Then this one you label it with letter Y. So just labeling like this, you can just put even in the first set to say this is A, this is B, C. And then the last, you can even end there, and then this can just be what your X, Y, Z. So for you to understand fully, to say this is a function, what are you supposed to do? For you to understand fully, you need to know that something to be called as a function, meaning that the corresponding values has to be mapping to each other. We call mapping of the functions this and that, and this and that, this one again and that. So the relationship between the first set and the second set is what we call a function, like this. So you are going to understand that here I can put a letter F to mean function. Okay, so someone can even ask you to say what is a function. You define what a function is. So a function F is a correspondence between two sets, that is set of X and set of Y. So as like I defined already, to say now this automatically, for you to have a function like this one from the set of X and the set of Y, they must match with one element only. So this has to match with that element, this has to match with this element, and this one has to match with that element. In other ways, all the sets in X values, we call them as domain, and all the elements in the set of Y, we call them as what? Range. Okay, suppose we have another set now. We have another set, this set. Okay, by the way, before you even move forward, you're going to understand that for something to be a set, remember we are matching these elements with the elements in where? In Y. Meaning that if you want to see if this is a function or not, automatically this has to be written like this. You say F of the elements in where? In X. F of the elements in X. So what you're going to understand fully in this case is, suppose here we have A, we have B, we have C, and also finally we have letter X to mean for set X and the set Y. So here, meaning that if you want to match all these elements in that format, you will find that here for Y you say F of what? F of A. You've replaced what there is what there is X. In this case, you put what? The corresponding variables to show that you are talking about this one as what? As your function. Okay, so what you're going to understand the most is this. Here we're going to have F of what? F of B in reference to this. Definitely here we're going to have F of what? C in reference to that. And finally, we're going to have F of X to mean that this is my what? My function. And then also what you're going to understand is, so this can be equivalent to that, this can be equivalent to that, this one equal to that, or this one again, it has to match with those So like we said, elements in X has to be called the domain, elements in Y has to be called what? Range. Okay, so what you're going to understand here, what name is given to this relationship? We say this has to be a relation. And how do you define the same relation? You find that a relation is just defined as a set of ordered pairs. A set of ordered pairs. So in the relationship, or in the relation in which no two ordered pairs have the same first elements. For example, we have this element, this type of a function. Suppose we have this function which is f of x is given as maybe 2x plus 3. Okay, so how can you indicate this one to say it has indicate that it has the values of x as the domain? Suppose we have x is equal to 1, x is equal to 4. Let's say maybe x again is equal to, put negative 2 here. What numbers are you going to get? So here you are going to say where there is x in this expression, you say f of 1, this is going to be equal to what? 2 open 1 plus 5, sorry, plus 3, and you'll be able to get what? 5. Secondly, if you say f of 4, you find that you will say 2 4 plus 3, meaning that f of 4 has to be equal to this is going to be equal to what? 11. Then whenever I try to go to the next thing, you say f of negative 2, it has to be equal to what? 2 negative 2 plus 3, which the answer here has to be negative 1. Okay, so since these are values of x, and here we're trying to find the set of y, which is what? F of y. The order here, if you say what, if they ask you to say what is the order of this, is going to be what? 1, 5. Here the order has to be what? 4, 11. And definitely on the last part here, the order has to be what? The order has to be negative 2, negative 1. Okay, I remember at your secondary level you learned something like suppose they give you a function. Good example which can be like this. A good example we can give is so we have examples. So we have if f of x is given as, if f of x is equal to x squared minus x plus 4, and g of x is given g of x is given as we can put, what expression can we give here? We can we say minus x square. So what is the question in this case? The question is just asking us to do what? The question is asking us to say we have to find a f of negative 2, then b we also have to find g of 4. So you can pause the video, you try to solve out these same examples before I even go into the next step. So here we are going to use the same format which I'm from doing here down there, the format which I'm from using here. You say where there is x, for this one you replace with what? And the value of x, and you're going to get that. Same applies even in this case. So we're going to say, I'm going to write solutions here. I'm going to write solutions there, and you're going to understand that if you say f of negative 2, what answer are we going to do? What answer are we going to get? So for a, we're going to understand that we're going to have f of negative 2 is going to be equal to what? You plug in the value of x where there is, the value of negative 2 where there is x, to be negative 2 square minus negative 2, and you'll be able to get f of negative 2 as 4 plus 2, which is going to be equal to plus 2, which is going to be equal to what? Sorry, I've forgotten one value here, which is 4. Add 4 here, so we're going to get 10. Then for b, you do likewise by plugging in the value of 4 there. So you say f of 4, this has to be equal to so this is going to be equal to, you take this 4 and put where there is x variables. We're going to have 4 to the power 3 minus 4 square. So 4 times, to the power 3, this automatically has to be equal to what? 60. It has to be 64 if I'm not mistaken. 64 minus 16. What answer are we going to get? Definitely we're going to get I think it has to be 48 if I'm not mistaken. Yeah, so that is based on the introduction to functions. It's just a recap to what you learned at your secondary level. So sometimes these same functions can be dropped or can be called, can be expressed in a form of pieces of functions, and here we call them piecewise functions or piecewise functions. And how can a piecewise function be expressed? So you find that, okay, just arrange this. Piecewise functions, how do we arrange piecewise functions? Okay, so how do you determine if a function is a piecewise function? So a function can only be said to be a piecewise function if it can be written in pieces or in piecewise intervals. For instance, if we have, suppose we have f of x, which is a piecewise function, and that it can be written in pieces as follows. It can have 2x plus 1 if x, say if x is greater than or equal to 0. This shows that we're having that interval. Then the other thing, you can draw it here or you can write it somewhere there, say plus 1, that is if x is less than what? Is less than 0. So if the function has been given like this and yet they want you to find, suppose they say, can you find f of 4. So what are you going to do? So I'll start with the first interval, whereby we are saying the first interval is saying that with the first interval. In the first interval we are saying f of, that is for what? For x being greater than or equal to 0. Then f of x has to be equal to what? The function which is on that given point. So you say this has to be what? 2x plus 1. So since we are saying f of 4 in this case, what are you going to do? You're going to find that it will be what? F of 4 will be equal to 2, 4 plus 1. This is just one and same like what? 9. And definitely if you get back to this interval, you find that truly 9 is what? Greater than 4. Then whenever you try to go back to less than, you try to go back to less than. So on less than, you find that we are having, here we made a mistake. This must be negative, just like this. So you find that we are going to have something like this. You say f of x equal to 3x minus 1. And definitely, if you say f of 4, this has to be equal to what? 3, then I put 4 minus 1. So I'm going to say, So definitely if you say 8 minus 1, then 12, not 8, 12 minus 1, this is 11, meaning that this function f of x can't be equal to what? Can't be equal to 3x minus 1, or in other ways it is not showing that x is less than that. Reason being, if you plug in this, you are getting a number which is greater than 0, meaning that this function does not qualify. So that was just a simple illustration on how you should resolve questions based on piecewise function, even come introduction to functions. So sometimes they can even ask you to say, can you check if a function, how do you check if a given function is one-to-one? So like we said, we draw something like this, and there I drew something like this, then here I had to put x, y, z. Here I put a, b, c. So this and this, they match each other like this. This is a one-to-one function. Why? Because one element is matching on what? One element. So suppose you want to use in a form of a graph. How do you test if a function is one-to-one function? We can only test by the use of what we call a horizontal test. What is my horizontal test? If you have quadratic function, we know that quadratic function, which is having this graph, y is equal to x square. If you get back to your secondary level, you understand that quadratic function is written like this. On that topic where you learned something like it to have a maximum, minimum, if this is positive, all those stuff we are going to learn as we are going into the details of function. So if you use a horizontal test like this, you do like this, you find that this line is going to cut the curve at two different points, meaning that this function is not one-to-one. Reason being, the line is cutting at two different points. Then whenever you try to check the other one again, if we have this type of a graph which is like this is for a modulus of x. We call this to my modulus. So if you use a horizontal test, by the way, we can't draw a line here, but you want to draw a line to the part where the function is, or the curve is, or the graph is, like this. Again, this one is having two different points. It touches at two different points. So 1 to 2 function, it can be like this. This can also be mapped at this given point. That's the meaning of this. So definitely, if it matches like this, this is 1 to 2. Sorry, this is 1 to many. Then if you keep doing the same thing, you try to draw this, which is for polynomial, the one which is having x to the power 3. You'll find that whenever, even if you have to draw a line here, you draw on top, automatically this is going to be one-to-one function. The reason being, the line only cuts the y-axis, the curve at one given point. So this is just an introduction to functions. Keep on watching as we are trying to have our online lesson in the other time. Thank you.